All right, so today we're going to move on to the third type of transformation that's called rotations. So our goal is to be able to perform rotations on images clockwise and counterclockwise by 90, 180, and 270 degrees. So let's look at some real life rotations real quick. A Ferris wheel is an example of something that rotates. It spins around that center point. So that's one thing that rotates. Clock, the hands on a clock are rotating around the face of the clock. And the Earth, it completes a rotation every day. That's how we get our 24-hour day, because it takes 24 hours for the Earth to rotate one time. So those are just some real-life rotations. Some other examples, if you guys are familiar with Shaun White, he's a professional snowboarder, and they do a lot of tricks in snowboarding. And some of the tricks, there'll be like a 1080 or a 540, 720. Well, that's talking about degrees of rotation, because what the snowboarder's doing is they're spinning around, in a circle. So that's where they get those numbers. It's how many degrees around they're rotating whenever they do those tricks. So if we look at a clock, what do you think clockwise means? Just kind of think about that for a second. What do you think clockwise means when we talk about something moving clockwise? What clockwise means is they move in the direction of the hands of a clock. So the hands of a clock obviously move this way, 1, 2, 3, 4, 5, 6. So that's clockwise. Anytime something spins or rotates in that direction, it's rotating clockwise. All right, so what clockwise means is rotating in the direction of a clock. So, of course, counterclockwise means rotating in the direction opposite the clock. If it's counterclockwise, it's the opposite of clockwise. So we say rotating in opposite direction of the clock. Alright, so it's important to understand that. Counterclockwise would be in the other direction. Okay, it doesn't have to start at 12 or anything. It's just which direction is it going, clockwise or counterclockwise. The red line goes the opposite way that the hands on the clock would move, so that would be a rotation counterclockwise. All right, so let's add some degree measures to these. So if we've got these hands on a clock, if we're going, let's say we're going from this clock to this one. Whenever we do rotations, we always want to tell the shortest measure that we're going to have to move. So the hands right here move from 12 down to 3. So they rotated this way. That's the shortest path. So that was a rotation clockwise. Okay, I'm going to put CW for clockwise. And if we added some angle measures, well, we can see that this makes a 90-degree angle. So that would be a rotation 90 degrees clockwise. All right. Now let's look, if we went from the first clock up here to the bottom right clock, what kind of rotation is that? Well, we started at 12 and rotated all the way around this way. That would be the shortest way. Or you could say this is the shortest way because it's the same amount, right? It just went halfway around. So either way would work because either way is the shortest way. We always want to say the shortest way. So how many degrees is that? Well, because those two form a straight line right here, a straight line's 180 degrees, so we could say it's 180 degrees, and we could say either direction because it's the same. So we could say 180 degrees clockwise, or we could say 180 degrees counterclockwise. Either one would be fine for that one because they're both the same amount, so the smallest one would be either one of those. So either direction works. Let's look if we went from the first clock to this bottom left clock right here. All right, so on this one, the shortest path is to go this direction. Right? Now, which direction is that? Is that clockwise or counterclockwise? Well, the hands on the clock would normally count up. 1, 2, 3, 4, 5, 6. That's going down. 11, 10, 9, 8, 7. So that's the opposite way of a clock. So that's going to be counterclockwise, the shortest way to go. And, of course, that's a 90-degree angle. So that would be a rotation 90 degrees counterclockwise. All right. So let's see if you guys can do these right here. Tell us at these three, how many degrees of a rotation is it, and which direction is it that makes it the shortest, clockwise or counterclockwise. So I'll go ahead and pause the video, give these a try, and see if you got them right. Okay, this first one is 90 degrees clockwise because the hand rotates in this direction, which is the shortest way, and it's rotating 90 degrees, so that's 90 degrees clockwise. The other one, the shortest direction, is to rotate counterclockwise, and that's also 90 degrees. And in the last one, you could have said either 180 clockwise or 180 counterclockwise. You could either go counterclockwise, or you could have gone clockwise. Either one would work because they're both 180 degrees, so either one's the shortest way. So you could choose either one of them. Let's look at doing some of these on paper with actual shapes on the graph. So for this first one, what you want to look for is how many quadrants did the points move. So we know we've got our graph divided into 4 quadrants, right? So if we highlight our axis here, you can kind of see you've got quadrant 1, 2, 3, and 4. So if we think about how many quadrants our shapes move, that will tell us how many degrees it went. Each quadrant that represents 90 degrees. So for example, let's look at point H. Remember, this is our original because there's no primes. So H, to find H prime, we got to go over just one quadrant from here. So every quadrant is 90 degrees. So since these points only moved one quadrant, that means we must have moved 90 degrees. So for number 1, we'd say 90 degrees. And which direction is that? So if H goes to H prime, that's going in this direction. So think about the hands on a clock, the numbers on a clock. You know, you've got 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going in the direction of the hands of the clock, right? It's rotating the way the clock's hands would. So that would be 90 degrees clockwise. And all the points move one quadrant. I moves one quadrant over. G goes from this axis to that axis. That moves one quadrant. And F moves from this bottom left quadrant to the top left quadrant. So if we're just saying the rule, we'd say that one moves 90 degree clockwise. Now let's look at number 2. So right here we've got, let's start finding our original points. And you can pick any point you want. So let's say we start with L. So where is L prime? Well, L prime is up here. So how many quadrants over is that? Well, L went 1 quadrant, 2 quadrants over. Right? Then just move 1, it moved 2. So like we said, every quadrant that it moves is 90 degrees. So that's 90 and 90 more, which makes 180. So we could say 180 degrees. Which direction? Well, it looks like that went clockwise. Or, remember, you could go this way and go 1, 2 quadrants and say counterclockwise. So whenever it's 180, either option works. You can say clockwise, or you could say 180 degrees counterclockwise. They could both be valid answers. All right, so let's look at number 3, and I'll let you guys try the last couple. So pick a point on the shape that has no primes. So let's say we start with S, and we find S prime. So S prime's over here. So that moved 1 quadrant over, so that's 90 degrees. And it's moving in the direction of the hands of a clock, right? If we keep going, we can see that's the way a clock moves. So we'd say 90 degrees clockwise. All right, so go ahead and pause the video. You guys try 4, 5, and 6, see if you can get the right answers, and then I'll show you the answers and you can check them. Okay, so on number 4, you can see if you start with the shape that doesn't have primes, we're going to move 1 quadrant over to the shape that does have primes. So if we go from L to L prime, that's just 1 quadrant, so that's 90 degrees. And which direction are we moving? Well, that's the opposite way the clock moves, so we'd say 90 counterclockwise. Number 5. So on number 5, we've got a shape right here with no primes. Here's the shape with the primes. So we're moving in this direction, and we're only going 1 quadrant. So that's 90 degrees. And we're going the opposite the way the clock rotates, so that's counterclockwise. Remember, if you need to highlight your axis to kind of see how many quadrants you're going over, then that's fine. Just highlight those. You can see you move from the top right to the top left. So you're just moving 1 quadrant. You shouldn't ever go diagonal quadrants. Like you wouldn't rotate that way. You got to go through one to get to the one down here. All right, so then number 6, if we start with this shape with no primes, so say start with S, whereas S prime, it's up here. So that's over 2 quadrants. So since it's 2 quadrants, that's 180 degrees. And with 180, you can say either clockwise or 180 counterclockwise. Either one would work. All right, so let us know if you have any questions. Appreciate your attention.